2018 ME10217.
217. Okay. So I will ask him if you have attempted, then it will be taken care of.
And ma'am, many others have also attempted, I think.
No, this is what information I got from TA that nobody has attempted. But if you have attempted and answered it somehow, then it will be taken care of.
Okay.
So probably you have not entered the answer in
No, entered answer also, but obviously I did not get any answer because we could not have solved it. But entered some answer.
you have entered the answer.
Some answer I have entered, ma'am, yes.
Okay. I'm sorry, I do not want to share the board screen. Okay. Can you see the screen?
Yes, ma'am.
Okay, so today we will start water quality parameters. We will learn about the water quality parameters. And there are broadly two categories of water quality parameter. One is physical, the other is chemical. Microbiological or is another category, but basically we will focus on physical and chemical. Water quality standards that are based on the limits, like the threshold limit above which there is a health risk. So that standard I am not teaching, but you can find out the water quality standard in any book. Indian standards are there. The standards for other countries will be seen in on website. So I'm not teaching that. Okay. Sources of pollution that we will cover with the water quality parameter itself. So it's the time is 8. What is the time right now? Let me just see what is the time. 1 minute. Okay, yeah. So we have the time has started. So first is physical water quality parameter, in which suspended solid is the first parameter. The suspended solid uh, can be defined as like the solid which remain floating in the water because of their weight is light, they are lightweight, and the particles like salt, silt, clay, and some other even very fine particle of sand which remain suspended in water, they are known as suspended solid. These material are undissolved, so they can be removed just by filtration. So when you filter the water through a medium, any kind of filter, glass fiber filter, quartz filter, then these material remain on the top of the filter along with some volatile solids also. So then what we can do, we can take the pre-weight of the filter, and then after filtration we can dry the filter at certain temperature, very low temperature, and then again take the post weight of the filter to know what is the amount of suspended solid. This suspended solid are objectionable because they, when you are drinking the water, it doesn't look good. You will not, it will not be pleasant, and you will not be like willing to drink the water where suspended solids are present. The suspended solids are also responsible for biological activity. They provide the surface for biological activity, which is disease-causing organisms. So therefore, we that is another reason for objection to this suspended solid. So permissible limit for suspended solid according to US EPA is given here. However, there are limits given by Indian Standards, Bureau of Indian BSI, BIS, right? Bureau of Indian Standards, that can be seen. Now, measurement of suspended solid, as I said, the suspended solid can be simply measured by gravimetric method by filtering the water or passing the water through the filter, either fiber filter. Sometimes you can also use the membrane filter, and whatever solid remain on the filter will be weighed again after drying the filter, and that will give you the you can say when you subtract the post weight pre weight from the post weight, it will give you the suspended solid mass. Now there are another category of solid in the water is dissolved solid. Okay, this dissolved solid which are they cannot be filtered. They will go through the filter and remain in the filtrate water. That can be determined by as a balance of total solid and suspended solid. Okay, now the total solid, how will you know the total solid? Can you tell me what would be the way to know the total solid? So here it's saying that suspended solid is obtained by filtration and heating the residue to 104 degrees centigrade, right? Total solid means the solid which has suspended solid and dissolved solid both. Dissolved solid can only be removed if you heat the filter at above 100 degrees centigrade. But this temperature should not be as high as like 110 or 120, because in that case there is a possibility of breaking of some of the compounds. So generally a temperature of about 104 degrees centigrade is being used to evaporate the dissolved solid from the filter. Okay, so total solid, if we want to know the total solid, what we can do, we can heat this filter at temperature lower than 104 degrees centigrade. So or dry the filter at temperature less than 104 degrees centigrade, and weigh the filter with solid which will have both the suspended as well as dissolved solid. Okay, so that is one way to know the total solid, and then deduct the suspended solid from that, it will give you dissolved solid. Total dissolved solid, a direct measurement of TDS can be made by evaporating or dryness of sample of water which has been filtered. The residue is wet. So this is what I was saying. You can just dry the filter at low temperature. Okay, at low temperature. Approximate analysis of TDS is often made by determining the electrical conductivity. Another way is to know the electrical conductivity of the water. That will also give you the total dissolved solid. The specific conductivity of water can be determined by means of portable diionic water tester. So there is a device which can give you the conductivity of water that can be translated into total dissolved solid. Electrical conductivity in micro ohm per centimeter at 25 degrees centigrade multiplied by 0.65. This is the formula to convert the electrical conductivity into dissolved solid. Okay, coefficient 0.65 varies with the type of the salt. So this particular coefficient is for a given salt, and you can find out. I just forgot to write the name of the salt here, but that can be found in SK Girl's book. So this coefficient may vary with the type of salt. So the conductivity meter is actually calibrated for different type of salts. okay, which may be present in the water, and therefore its scale is set to translate the conductivity or to translate the amount of salt into conductivity, whatever you can say. So the scale is actually made in such a way that for different concentration of salt and for different salt, a factor can be or factor can be given to translate the concentration into conductivity, or if you know the conductivity, it can be translated to the concentration of the dissolved solid. So is that clear? Is this clear? Hello? Anyone?
Yes, ma'am. That's clear.
Okay, okay. So now, so this is how the total suspended solid, dissolved solid, and suspended solid can be determined in a water sample. And why do we know? Why do we want to know the suspended solid concentration? Can anybody say? Yes, it is objectionable to have the suspended solid in drinking water, but once we know the suspended solid, the amount, as well as sometimes um, the size distribution of suspended solid can also be determined by one of the equipment that is known as dynamic light scattering, DLS, dynamic light scattering, one instrument that will give you even the size of the particle. So once we know the amount of the suspended solid, we can design the different water treatment unit which can remove this suspended solid. Okay, so that is why the water sample should be analyzed in the laboratory to know the concentration of suspended solid. Now, turbidity. Suspended solid can be removed easily. However, there are possibility of having the colloidal particle in the water, and that produce the turbidity. Yes, the suspended solid will also produce the turbidity. However, suspended solid can be removed by a simple filtration method, but the colloidal particle may not be easily removed just by filtration. And the turbidity is one of the problem, even though the suspended solids you can say not present in the water, they are absent. But if water is even little turbid, it is not advisable to drink the water, or you means the person will not like to drink the water with little turbidity even. So turbidity is a measure of extent of the light which is either absorbed or scattered by the suspended material, but these materials are mostly colloidal material, very, very small in size. So we can measure the turbidity also. That will also give us a quantitative measurement of suspended solid, but of very fine size. Means that is another way. Means even the large particle is present, uh, that can also be measured in terms of turbidity. I'm not saying that the large particle cannot be measured, but turbidity mostly when it is associated with water, we think like it's a means it's kind of colloidal particles impart more turbidity in water. Okay, so this light scattering or absorption method is very common method to calculate the turbidity. Objection, as I said, nobody will want to drink the water which has turbidity in it, and disinfection of the turbid water is difficult because it will consume more disinfectant. In natural body, turbidity interferes with light penetration and hence the photosynthesis reaction. So that's why turbidity is objectionable. Now there are two methods. One is turbidity rod, the other is Jackson turbidity meter. These are the first one is field instrument that can be used in directly in river body or any water body. Jackson turbidity meter is a laboratory method. In first method, the rod which has like metallic rod which will have a platinum needle on the bottom can be inserted into water, and until this needle is invisible, okay, till means the depth up to which this needle is invisible will be translated to the turbidity of water. If water is less turbid, the reading will be low. If water is highly turbid, we have to insert this like at even at the low like less distance, this needle will not be visible. Therefore, the graduation of this scale will be what? Downward it's high and upward it's low, right? So it depends. So here this particular method is good for even like you can say turbidity which 1 milligram. Okay, that is the definition and scaling of the rod. But it is good for low turbidity like 5 to 10 ppm and so on. So you can measure the turbidity in that range. Turbidity, actually this scale is graduated by measurement of turbidity of a water with a given amount of the salt. Okay, so graduations are made by you can say putting the given amount of the salt. Generally, see here it is written turbidity which 1 milligram of finely divided silica produced in 1 liter of distilled water is taken as 1 unit. Okay, so the whole calibration of the scale or the graduation of the scale is based on that putting the salt in 1 liter of distilled water. With the increase in the amount of silica or the salt, whatever, it will the turbidity will increase and therefore the graduation will decrease. Okay, no, graduation will increase, right? So it's a like, how can I say? Is that clear what I told you just now, or is that clear? So
Ma'am, please explain this point again. As depth of insertion
let's
increases, reading will decrease.
yeah. Yeah, so at less distance, the needle will be invisible. If water is clear, then at very more distance, at higher distance, the needle will be invisible. So the ppm on the top of the scale will be low, and it will gradually increase with towards the bottom. Okay. The extent turbidity meter is again a kind of device which works on light scattering, right? And so here a candle is placed below the turbidity meter, and the transmission of light through a water column can be observed. Depending upon the transmission of light, the turbidity of the water is translated. And again, this graduation of scale you can see here is also based on the known concentration of salt dissolved in water to determine the turbidity. So these are very simple instruments which are based on the known salt and the known quantity of the salt. The scale is graduated in such a way that light scattered through the water column can be translated to the turbidity. Okay, there are another device. You can go through this. This is again Nephlometer is actually the basic difference between these two devices, Baylis turbidity meter and nephlometer is, in Baylis turbidity meter, the scattering or light scattering is measured in the direction of incident light. Means in the opposite direction. You can see like while in nephlometer, this the scattering is measured at 90 degrees of the direction of incident light. That is the only difference, but the principle is same in these two devices also. So and similar to the earlier device, which is Jackson turbidity meter. Now, color is one of the parameter which again it is not means you can say unpleasant to see the water, colored water, while especially while drinking the water, and color can be imparted by various oxides, metallic oxides like iron oxide, which gives the reddish color, manganese oxide, which gives the brownish color, or sometimes blackish water. So color is imparted by various oxides of metals, and it is objectionable. It is also reduce the effectiveness of disinfection process while treating the water. So some of the phenolic compounds with chlorine produce taste and odor both as well as color. So therefore these compounds and oxides of metals are actually not desirable, especially the oxides of metals are not desirable above the certain limit, and phenolic compounds are not at all desirable in drinking water. Okay. Now measurement of color. The measurement of color can be done with tintometer. So 1 TCU is equal to color produced by 1 mg per liter of platinum in the form of chloroplatinate. So what it's saying, how this particular device is being graduated, or the scale is being graduated. This is what is the method. One turbidity, one tintometer unit TCU, which is true color unit, is equal to color produced by 1 mg per liter of platinum in the form of chloroplatinate ion. Okay, it is only for yellowish brown color. So this particular platinum or chloroplatinate ion is used only to identify the brown color, okay, yellowish brown color. So this color of this color produced by particular ion, platinum, which is chloroplatinate ion, is compared with the actual color of actual water in order to, you can say, determine the color of actual water. So it's a comparison kind of method. For color other than yellowish brown, for industrial effluent, spectrometric technique is used, and the color testing is done within 72 hours of collection, as otherwise biological or physical properties may change. So actually spectrometric techniques are most common techniques to not only for color, mass spectrometer, or there are other techniques which are used to even determine the odor and taste in water. Okay, so spectrometry is more precise, you can say, technique for color, odor, taste measurement. Taste and odor measurement, or these are another physical water quality parameter that are caused by the gases like H2S, hydrogen sulfide, mercaptans, methane, organic matter derived from certain dead or living organisms, decomposing of organic matter, industrial liquid, and so on. So phenols and other ammonia, other things which are present in water can also impart taste and odor to water. Sources, there are many sources. Basically such compounds generally come from to dispose of any kind of even disposing the dead body in water is not advisable, because that will again cause a taste and odor in the water. Any animal dead body or human dead body, this is something which is unadvisable. Then the sources, other sources are industrial sources. If the industries are using various compounds, phenolic compound and sulfur-related compound, then there is a problem of H2S probably in water. If the sewage, untreated sewage is disposed in water body, then there is a problem of H2S in water. So all these are the sources, and um, taste and odor is actually a very, you can say, undesirable parameter, and it is totally objectionable to have such water for drinking purpose. Some of the compounds could be carcinogenic also. Like I said, phenolic compounds, they are carcinogenic in nature, and therefore they are not desirable at all. Measurement of taste and odor, this is the technique which can be used. Everything is written here, you can go through it. I'm not going to read it. Or just I will say that osmoscope, let's see where to. Odor can be removed by mechanical aeration. Okay, that is the removal of. So I think the formula for TON, right? TON is threshold odor number. Threshold odor number means the it represents the dilution ratio at which the odor is hardly. So the if you have a odorous water and you dilute the water until the odor is disappeared, until you will not feel the odor, that is that dilution ratio is actually indication of odor, and it is given as threshold odor number. And threshold odor number is equal to A plus B upon A, where A is the volume of odorous water, which is water sample, and B is the volume of odor-free distilled water or whatever deionized water, which is used to dilute the water sample, and divided by A. So A plus B upon A will give you threshold odor number. Then temperature generally 25 degrees centigrade temperature is good temperature for drinking water supply. Means high temperature water, people they do not like it. However, there is no harm in using like even the water with 30 degree or 35 degree centigrade temperature, but it is objectionable to supply the water above 25 degrees centigrade. Now, chemical water quality parameter. The very important parameter is alkalinity. Alkalinity is the presence of carbonate and bicarbonate ions, either calcium carbonate, magnesium carbonate, or bicarbonate. All these ions which are enough to neutralize the hydrogen ion present in water. So if you are adding the acid in a water sample, until the all H plus ion added by the amount of acid is neutralized by carbonate and bicarbonate, that amount of carbonate and bicarbonate are known as alkalinity. And generally alkalinity is represented in terms of calcium carbonate. So all the salt of carbonate and bicarbonate will be converted or to the equivalent of calcium carbonate, okay, in calculation of alkalinity. So to bring all the salt on a common scale, okay, that is the reason behind this. So minor sources of alkalinity could be hydrogen silicate, dihydrogen perborate, hydrogen phosphate, ammonia, hydrogen sulfide, etc. However, these are the minor compounds or minor ions, and basically we do not consider them until and unless it is given that these ions are also present and their amount would be given in the problem. Mostly for routine purpose, routine water testing purpose, carbonate and bicarbonate are being used for alkalinity calculation. Total alkalinity is therefore given by carbonate ion concentration, bicarbonate ion concentration, hydroxide ion concentration minus H plus ion concentration. The pH we know it's a negative logarithm of hydrogen ion concentration, and it can be measured by potentiometer. This is the example of it. Is there any question till this point? If there is anything unclear or you think like there is any mistake in the PPT, I will rectify it.
Ma'am,
Hmm?
in the previous slide,
Hmm?
should we use a multiplication factor of 2 with the carbonate ion?
Multiplication of factor of 2 with the carbonate ion for what?
Because it can neutralize 2H plus.
Yeah, let's see the reaction. I will tell you the reactions in the next slide and so on. Okay. We will see the reactions.
Okay.
Okay. Is there any other question? Okay, so there is no any editing formatting mistake or like if there is any, because there are so many ion formula and these are written, so maybe sometime I just checked in the morning, so there was very minor mistakes were there, but I have some, if even some mistakes are there, just let me know. Before uploading the PPT, I will correct it, okay? Alkalinity caused by, so the example is saying the alkalinity caused by 90 mg per liter of CO3 2 minus means carbonate ions and 61 mg per liter of bicarbonate ion can be calculated. Okay, so when we say that we want to calculate the alkalinity caused by carbonate and bicarbonate ion, then it means that we have to convert this amount into equivalent calcium carbonate. Okay, this is what it means. So for carbonate ion, as a CaCO3, it will be 90 is its amount of carbonate ion multiplied by molecular weight of CaCO3 divided by molecular weight of CO3 2 minus ion. Okay, so this 90 into 100 upon 60 is 150 mg per liter will be the amount of carbonate ion as CaCO3, right? But when we talk about bicarbonate, then 2 mole of bicarbonate ion is associated with 1 mole of calcium. Okay, so in this case, generally this is the reaction given. In this case, then we convert HCO3 as CaCO3, then we take the amount of SCO3 given in the example or in problem multiplied by molecular weight of CaCO3 divided by molar weight of 2 mole of SCO3. Okay, this is what you were saying, right? You just
No, ma'am. I was saying that we define alkalinity by how much H plus ion it can neutralize. So
okay.
in the case of CaCO3, if I react it with H plus, it will consume 2H plus or 1H plus. Like CO3 minus will convert to HCO3 or H2CO3.
H2CO3, H2CO3, or then it will finally convert to HCO3 and associate, like it will react with calcium carbonate and form calcium bicarbonate, right? Means H2CO3 is not a stable ion, right? I did not get your question.
Maybe, ma'am, I will read the slide again and then I will
Okay.
ask in the next class.
Maybe, okay. So this is how we can calculate the bicarbonate ion concentration as CaCO3 is equal to 61 is the amount given for bicarbonate ion concentration. Equivalent CaCO3 can be calculated by 100, which is molecular weight of CaCO3 upon 2 mole of bicarbonate is associated with 1 mole of calcium, so 2 into 61 calcium carbon, like 1 mole of calcium carbonate is needed to get calcium bicarbonate, where 2 HCO3 is associated. So therefore, this is 50. Now total alkalinity of carbonate and bicarbonate is 150 plus 50, which is 200. Now, if in example, if pH is not given, then we can ignore any alkalinity due to OH minus and H plus ion. But if that is given, then we have to go further to calculate. For example, here the H plus ion concentration is given as 10 raised to minus 10 mole per liter. So if I want to convert it to mg per liter, then this is how we can convert it, right? 10 into 10 is to minus 10 mole per liter multiplied by molecular weight, right, which is in gram per mole. So gram per liter will come, and then you can convert it to mg per liter. So 10 is to minus 7 mg per liter is the H plus ion concentration. Now, what would be the reaction between H plus ion and calcium carbonate if present in water? So calcium carbonate plus 2H plus will give you Ca2 plus H2CO3. Okay, and 2OH minus plus H plus will give you 2H2O. Okay, so H plus alkalinity SCaCO3 can be determined as 10 raised to minus 7 is the amount, 100 upon, because 2H is required to make H2CO3, and it is reacting with 1 mole of CaCO3, so 100 upon 2. So CaCO3 molecular weight will remain 100 only, but the molecular weight of H plus ion would be 2 into 1, right? So 2. So this is 5 into 10 raised to minus 6 mg per liter H plus alkalinity due to H plus ion, which will be deducted. It will not be added into total alkalinity. OH minus ion concentration is given as 10 raised to minus 4 mole per liter. Okay. Therefore, 10 raised to minus 4 into what is the molecular weight? 17 gram per mole. It can be like the in mg per liter, it is 1.7 mg per liter. Therefore, OH minus ion alkalinity as CaCO3 is 1.7 into 100 upon 2 into 17, because 2 OH minus ion reacts with H plus ion. I think there should be some reaction with CaCO3. Oh, okay. Okay, I think one right? I'm missing one reaction over here. Do you also think that there should be reaction between CaCO3 and OH minus ion, right? Did we see that reaction previously? No? No? Okay, how many of you think that the one reaction is missing over here? Or I'm like thinking it in a wrong way? There should be one reaction which should be between CaCO3 and OH minus, right? Then only this formula will be used, no? 2 into 17, so this is 5 mg per liter of food. Okay, anybody who want to say something? Okay, if you do not want to say
Ma'am,
anything, yeah.
evolution of CO2 from CaCO3 and formation of CaOH twice.
What?
Evolution
Say it
of
again.
CO2 from CaCO3 and formation of CaOH wood.
Evolution of CO2
Yes, ma'am. From
from
CaCO3 when it
CaCO3.
decomposes to CaOH wood twice and CO2.
Okay, let me see the reaction. I don't remember, but does it happen actually? CaCO3 decomposes into
And that will
CO2?
lead to formation of CaOH wood twice from where the OH minus ions come from.
Okay, let me see. I have to find out. I don't remember the reaction. Okay, I will see if what you are saying is correct or not. Okay, I don't remember it. So, however, this is how the OH minus ion alkalinity can be calculated, and therefore total alkalinity will be equal to carbonate, bicarbonate plus OH minus H plus, right? So this is approximate alkalinity in terms of CaCO3. I will upload some of the unsolved question. You can go through the question and solve it. Maybe it will clear. And also, if possible, do you have SK Garg's book? I told you to buy the SK Garg's book, is right? It's a second-hand copy is available. Okay, let me see if I can scan some of the pages and put on MS Teams. Then another water quality parameter, which is chemical parameter, is hardness. Hardness is similar to what we have learned about the alkalinity, except the difference is hardness could be because of any multivalent metallic ion, because of their carbonate, bicarbonate, or non-carbonate compounds. Okay, just mute your mic. Please mute your mic. Okay, can you hear me now? Okay, so uh, so hardness is because of multivalent metallic ions which form carbonate, bicarbonate, or even non-carbonate compounds. Therefore, hardness will always be greater than or equal to alkalinity, right? Hardness can be divided in two parts: carbonate hardness, non-carbonate hardness. Non-carbonate hardness is basically like sulfate, calcium sulfate, ferrous sulfate, and so on. There might be other compounds also. So carbonate and bicarbonate of calcium and magnesium cause carbonate hardness, and they are also known as like alkalinity. Their presence is also defined as alkalinity of the water. It is also called temporary hardness because the hardness can be removed by just simply boiling the water. So this is simple hardness which can be removed by boiling the water. Objection: this lead to greater soap consumption. So hard water means the soap consumption will be high because it will restrict the formation of foam when you use the water with soap. Scaling of boiler may happen, causing it can cause the corrosion, right, of the pipeline. It makes the food tasteless and so on. So this is total hardness, which is the hardness due to as a CaCO3. Again, hardness is also presented as calcium carbonate, equivalent to calcium carbonate. So Ca2 plus hardness is equal to mg per liter of Ca2 plus ion present in water multiplied by molecular weight of CaCO3 upon molecular weight of Ca2 plus. Okay. Mg2 plus ion present in water in terms of mg per liter multiplied by molecular weight of CaCO3 upon molecular weight of Mg2 plus ion. So this is the problem, and it is solved. You can just go through the problem. There is nothing special, or you can say it's a very simple problem, and you can go through it. Now, the another water quality parameter is presence of phosphorus and nitrogen. Okay, nitrogen can be present in terms of nitrate or nitrite. Okay, nitrite indicates phosphorus. It's a like simple. Um, Phosphorus is not toxic and do not present direct health threat. It facilitates rapid growth of aquatic plant because it's a nutrient for the plant. It interferes with water treatment like chemical coagulation, etc. So phosphorus is not desirable in water because it will increase the cost of water treatment. Nitrogen content, presence of nitrogen in water indicates presence of organic matter. It occurs in the form of free ammonia, which indicate recent pollution, organic ammonia indicating the quality of nitrogen before decomposition has started. So it's a organic ammonia. If organic ammonia is present, that means the decomposition is going to start. Nitrate indicates partly decomposed condition, and nitrite indicates partially decomposed condition, and nitrate indicates old pollution, means fully oxidized decomposed uh, condition of nitrogen inside the water. Free ammonia should not be more than 0.15 mg per liter, and it can be measured by simply boiling the water and measuring the liberated ammonia by distillation process. Okay. Organic ammonia should not be more than 0.3 mg per liter, and it is measured by boiling a sample of water, of already boiled water which was previously boiled, and ammonia is removed after adding strong alkaline solution that is potassium permanganate. This is potassium permanganate, right? KMnO4. I forgot the name. KMnO4 is what?
Pot- Potassium permanganate.
Okay, so I'm right. Okay. Potassium permanganate, and measuring the ammonia so liberated. So in this case, the organic ammonia is converted to ammonia by using a very strong oxidant, which is potassium permanganate, and then the ammonia which is liberated during the boiling of water is again measured with same process, which is distillation process. I am not teaching the distillation process. If you would like to know about it, let me know. I will add some of the points related to this process. Free ammonia plus organic ammonia is known as Zeldal nitrogen ammonia. Okay, so Zeldal is very common. You can say experimental device which is used uh, in in um in laboratory to determine the total ammonia, free ammonia and organic ammonia. Nitrite is highly dangerous, responsible for blue baby syndrome and or you can say methemoglobinemia. Okay, so it's a it actually reacts with you can say oxygen in the blood. Hence, it is not permissible. It should not be present in the water. Children suffering from this disease may omit, their skin color may become dark blue, dark, and may die in extreme cases. So actually, the problem is nitrite can react with hemoglobin and hemoglobin. I think not oxygen. Let me just see if I have. Oh, I did not include. Okay, I have to correct this slide. I have to include the information on blue baby. I will do. So other chemical. Yeah. Yes.
Ma'am, how phosphorus is present in the water in the form of which, like it is like a phosphine or phosphide or something else.
Which compound?
Phosphorus.
Phosphorus. I don't remember exactly in what form phosphorus is present, but it is a nutrient for aquatic plant that I know. Let me see in what form it present in water. I don't remember exactly. Okay, I will add that. Good point. Is there anything else which is like you think is missing and the connectivity of these points are not clear? The points written on this slide. Okay, I will include about the phosphorus as well as I will include some more information about blue baby disease. Fluoride up to 1 mg per liter. This is liter, not 1. It helps to prevent dental cavity. It combines chemically with tooth enamel, resulting in harder, stronger teeth and that are more resistant to decay. However, excess fluoride is not desirable because excess value results in decoloration of the teeth and even mottling of the teeth. Means, in infant, you can see there is a problem, teeth problem. Their teeth get black and they break, in various places. There is a how can I say, it's a breakage of teeth on the and blackish in color. So greater than 5 mg per liter causes deformation of the bone called bone fluorosis. Metals, there are several metals present in the water, basically calcium, potassium, sodium, iron, and manganese, and Zn are non-toxic metals, while arsenic, barium, cadmium, chromium, cyanide, lead, mercury are toxic metals. So generally the toxic metals are not desirable at all, as we all understand. In terms of non-toxic metal, there is a certain limit for some of the metal which is desirable. However, excess amount of metal or metal oxide is not desirable because they impart the color to water and they cause other problem in water treatment. Biological water, yes.
Ma'am, in the previous slide, it is written that it is 1.522 ppm. How we convert ppm to mg per liter?
So using it's a parts per million, no? You can see this like using the molecular weight and all, you can convert it. I think this we have done in air pollution to convert ppm to
yes, ma'am.
mg per liter.
Ma'am, we use, but I'm saying that all the other data are given in mg per liter. So this is only one which is given in ppm in the slide.
Yeah, it can be converted into mg per liter. Let me do it next time. I will include it. But it's a simply the way we have done in air pollution. The simple way can be used here also.
So, ma'am, we
Okay.
consider that there are like 1 billion molecule of water, and in which there are
Yeah,
two
and
fluoride.
1.5. Yeah, 1 parts of fluoride is, or by volume you can say, by volume 1.5 volume of fluoride is dissolved in 10 raised to 6 volume of water. So generally ppm here would be volume by volume or mass by mass basis. Okay, when we convert it to mg per liter, then we have to take the molecular weight to calculate it. It's mg per liter. I will include that calculation. Okay. So metals. Now biological water quality parameters. So
Ma'am, it's
biological.
8:53. Can we do the rest in the next class?
Just this is the last slide. I think no. There are no slides. Okay. So 3-4 slides are remaining. We will take it in the next class. You can leave the class. When is your next class?
At 9 o'clock.
Okay, 9 o'clock.
Hello,
Okay.
ma'am. I just had a small query.
Yeah.
I joined at 8 a.m. So I wanted to know if you have discussed about that question which had wrong values. So what's your final takeaway on that?
The question regarding the balloon question, right? I told that if you have solved the question and you have uploaded it and even put the value in the Moodle, then it will be checked. However, my TA informed that nobody has attempted the question, but I will ask him again to look into the matter.
Okay.
Yeah. So if you have attempted the question, it will be checked. If you have not attempted the question, then there is no.
And ma'am, can you also please ask him to do this all today only, so at least we know our marks.
I will ask him.
And ma'am, today is the last day also to share these minor marks as per the institute calendar.
Yeah. So he has already sent me the minor one marks, and I will share with you. However, this query he will resolve probably today evening or tomorrow morning. I will share the marks. Okay.
Yes, ma'am. Please resolve this query of balloon also, as many people have attempted, ma'am. I don't think that what he is telling you is correct. Like many people have attempted that
Let me
question.
see. Let
We
me see.
also
I
attempted,
will.
but we didn't mark it in the exam because it was wrong. So,
What?
ma'am, we attempted, but we didn't mark it in the online paper.
Okay, if you have attempted and you uploaded your sheet, then let me see and I will ask him to check. Okay?
Okay, ma'am.
Okay. Okay, thank you.
Ma'am, but I didn't write it in my sheet because I wasn't able to solve the question. I just wrote some basic data. I solved it in rough, and I don't know where that paper is.
No, if you have uploaded the whatever, even if you have solved it wrong or the question was wrong, if you
Ma'am,
have
but
uploaded it,
if the
then
question
only it
is
will
wrong,
be.
then shouldn't there be bonus marking for the question?
No, I'm not giving any bonus marking for the time being. Let me see how the other exam goes, then I will decide. Okay, that is, yeah, I know that was a mistake, but if you understand the concept, you should have attempted it. If you have attempted it, you will get the mark. If you have not attempted it, then there is a question of getting
So
the
these
mark.
marks, they will be reflected on Moodle, right, ma'am? Like on Moodle right now, we cannot see our marks.
No, it will be reflected on Moodle. What do you mean by that?
No, like I mean, when we had given the paper, after that our marks were visible on Moodle.
Yes.
Now, due to some reason, I think the TA has switched off the visibility of the marks. No one can see the marks now.
Okay. Okay. What I will do, if you have got the mark in that particular question, it will be added separately in Excel sheet where the mark is.
Okay,
The
so ma'am,
total.
will you share this final Excel sheet of marks so that we can see whether we have got the marks or not?
Yes. Yes.
Okay.
Okay. Okay. Okay. Bye. Is there any other question? Then we will leave the meeting. Okay. Bye.